Everyone, so this is Learn with Israel, and in today's video we're discussing atomic structure, isotopy and electronic configuration for chemistry in preparation for the upcoming examination. So we will be starting with the introduction to the atom. Introduction to the atom. So atoms are made of subparticles. Atoms are made of subparticles. And atoms are made of three subparticles, namely proton, neutron, and electron. Proton, neutron, and electron. So this proton is positive. Proton is positive. Is positive charge. Proton is positive charge. Neutron is neutral, which means neutron has no charge. It has no charge. And while electron is negative. Electron is negative and it has negative charge. Electron has negative charge. Proton has positive charge. Electron has negative charge. While neutron has no charge. So proton, neutron, electron are made of the atom. They are made up of the atom. So for proton, this is how the proton looks like. I hope you can see this well. This is how the proton looks like. You can see it is positively charged. It is positively charged. For the electron, you can see the electron is negatively charged. So this is how the electron looks like. So now we know that proton, neutron, and electron is composed by atom. So atom consists of proton, neutron, and electron. So you can be asked that what constitutes atom. You can be asked that examples of subparticles of atom include, you should know that it is proton, neutron, and electron. So now the next thing we'll be discussing is atomic number and mass number. We need to know atomic number and mass number. So atomic number we've discussed on introduction to the atom, which consists of proton, neutron, and electron, which are composed of the atom. So now let's discuss atomic number. Let's discuss atomic number. So atomic number is the number of proton. Atomic number is the number of proton in the nucleus. The number of proton in the nucleus. So what is the atomic number? Atomic number is the number of proton in the nucleus. So now let's discuss the mass number. So mass number, we need to know mass number and atomic number. It is very essential in this particular topic. So our mass number is the sum of proton. Mass number is the sum of proton and neutron. Sum of proton and neutron in the nucleus. In the nucleus. So the formula, if you are asked to calculate the mass number, of oxygen, for example, the mass number of oxygen will be proton plus neutron. Why? Because we said here that mass number is the sum of proton and neutron. So mass number of oxygen, the atomic number of oxygen is 8. The atomic number of oxygen is 8. So if we are asked to calculate the mass number of oxygen, it will be proton plus neutron. So the mass number of oxygen is 16, while the atomic number of oxygen is 8. So it is written as 16 as the mass number and 8 as the atomic number. So atomic number can be represented as Z, while mass number is represented as A. So make sure you take note of that. Mass number is represented as A, while atomic number is represented as Z. And the one here is the atomic number, 8 is the atomic number, while 16 is the mass number. So I'm citing this as an example. So if you are asked to solve the mass number for hydrogen or calcium, you should be able to do that using this method. So now the next one we'll be dealing on is isotopy. So now we've discussed. So if you have any question, you can drop it on the comment section. If you have any question to ask. So far we discussed the introduction to atom, and we talked about atomic number and mass number. So now let's talk about isotopy. So I hope you can see it clearly. I hope you can see well. So isotopy. So we all know that isotopy is the same, and for those that don't know, isotopy is a phenomenon. Make sure you have your notes to jot these important things down. Isotopy is a phenomenon whereby same elements have the same atomic number, but different mass number. So I'm going to cite like 3 examples for better understanding on that. So examples that we are going to use, chlorine. We're also going to use carbon and oxygen. Chlorine, carbon, and oxygen. So for chlorine, we all know that chlorine is written as Cl. So the atomic number of chlorine is 17. While the mass number is 35. And chlorine can also be written as 37 and 17. This 17 is the atomic number, while this 37 is the mass number. So you can see now that chlorine have 2 isotopy. So if we go back to the definition of isotopy here, isotopy is a phenomenon whereby same elements have the same atomic number but different mass number. So let's come here. You can see now that we have same element here, different mass number and the same atomic number. We have 17 as the same atomic number, but 35 as mass number. And for this one, guys, we have 37 as the mass number. Another example, so let's use carbon as an example. So carbon can be written as carbon can be written in three ways. Carbon can be written in three ways. So we have 3 carbon. What is the difference? The difference is that we have same atomic number but different mass number. Same atomic number but different mass number. So the last example is oxygen. We also have more hydrogen. We have 3 types of hydrogen, and what differs is the mass number. So for oxygen, the atomic number of oxygen is 8, while the mass number is 16. And we also have another oxygen that the atomic number is 18, while the mass number is 18, while the atomic number is 8. Why? Because of isotopy. Because we said earlier that isotopy is a phenomenon whereby we have same elements having the same atomic number but different mass number. So with this, you should have a better understanding on the isotopy, on how isotopy differs, using the example of each element including chlorine, carbon and oxygen. So now let's move to calculation of relative atomic mass. Calculation of relative atomic mass. Calculation. So make sure you get your jotting notes so we can solve questions on calculation of relative atomic mass. Relative atomic mass, also known as R.A.M. R.A.M. So the formula of relative atomic mass equals mass 1 multiplied by the percentage, the first percentage, open bracket, close bracket, plus mass 2 multiplied by the second percentage, all over 100. So I'm going to drop question that we are going to use using this formula. So example 1, element X has isotopes 39X and 90%, and it has 41X 10%. 41X 10%. So how do we solve this kind of question? We have our formula here. You just input it. So our R.A.M. equals, our first mass is 39. How do we know that our first mass is 39? Because I said earlier that 39, this one up here is the atomic mass. The superscript, this is called superscript. Superscript is the atomic mass, while the one here is the subscript. So our atomic mass is 39 multiplied by our percentage. So our percentage is, the first percentage is 90%, open bracket, close your bracket, plus our second mass. Our second mass is 41. So 41 multiplied by 10 all over 100. So our R.A.M. equals 39 multiplied by 90 will give us 3510. Press your calculator to confirm that it will give us 3510 plus 41 multiplied by 10 will give us 410 all over 100. So 3510 plus 410 will give us 3920 plus 100 all over 100. So 100 divided by 3920 would give us 39.2. 39.2. So our relative atomic mass is 39.2. So let's solve another question on the calculation of relative atomic mass. On relative atomic mass. So question 2. Elements. Can we see it clearly? Element 4 exists as 39y and 40y. So this 39 is the mass number and this 40 here is also the mass number in a ratio 3:2. So this one is a little bit different from the last question we solved, 3:2. So how do we solve this? The first thing to do is to add up your ratio. 3:2, that will be 3 plus 2, which will give us 5. So now the next thing is to use one of this. And how do we use it? 3 all over 5, which is the addition of the total ratio, multiplied by 39 plus, let's do the one for this second one, which is 2. 2 plus 2 all over 5 multiplied by 40, multiply with the mass number, multiply by 40. So 3 all over 5 multiplied by 39 plus 2 all over 5, 3 all over 5 multiplied by 39 will give us 23.4 plus 2 all over 5, 5 divided by 1 here, 1, 5 divided by 40 is 8. 8 multiplied by 2 is 16. So 23.4 plus 16 will give us 39. It will give us 39.4. So that is our R.A.M. So the next thing we are dealing with is the electronic structure of an atom. Electronic structure of an atom. So under electronic structure of an atom, we have what we call orbital. So I hope you can see clearly now. If you can see clearly, please drop it in the comment section. So electronic structure of an atom. The first thing to know under electronic structure of an atom is orbital. So orbital is a region in space with the maximum probability of finding an electron. So we have types of orbital. We have examples of orbital. We have S, P, D, F. The examples of orbital that we have S, P, D, F. I know you should be familiar with this S, P, D, F. So I will explain the characteristics of each orbital starting from S to P to D to F, because questions do come from this angle. Questions come from this area. So let's start with s orbital. S orbital is, it has a spherical shape. It has a spherical shape, just round like a ball, and it can only contain two electrons. It can only contain two electrons. So the maximum electron S can contain is 2. So we are still going to get there why s orbital can contain only 2 electrons. We are still going to get there. So the next one is p orbital. So p orbital, it has a dumbbell shape. So s orbital, you can be asked that how does the shape of s orbital looks like? S orbital has a spherical shape. P orbital has a dumbbell shape, and it can only contain, p orbital can only contain 6 electrons. It can only contain 6 electrons. So we also have d orbital. D orbital has a double dumbbell shape. It has a double dumbbell shape. It has a double dumbbell shape, and it can only contain 10 electrons. 10 electrons. So make sure you take note of this. D orbital has double dumbbell shape, and it can only contain 10 electrons. So now let's talk about the last one, which is f orbital. F orbital has a complex shape. It has a complex shape, and it can only contain 14 electrons. I am writing in this way so that you can be able to jot this note down, because it is very essential. So now that we know the characteristics of each orbital starting from s, p, d, f, so the next thing that we are going to deal with is how to write electronic configuration. For any element. Make sure you take note of this. Please make sure you like this video, share and subscribe. And if you have any question, drop it in the comment section so I can answer it. So how do we write electronic configuration? We need to know this. This is how to write it. We have 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 7s, 7p. So it will be like this: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, like this. Can we see now? So it will now be 1s, 2s, 2p, 3s, 3p. It will always start from here: 3p, 4s, 3d, 4p, 5s. You now start from here again: 4d, 5p, 6s, 4f, 5d, 6p, 7s. You now start here again. 5f, 6d, 7p. So now we know how to draw this electronic configuration. So let's start with writing the electronic configuration for elements. So exercise 1, write the electronic configuration of the following elements. So we have oxygen, chlorine, magnesium, silicon, and calcium. So if we are asked to write the electronic configuration of each element, what are we going to do? So we start with oxygen. The atomic number of oxygen is 8. And we said earlier that S can only contain 2 electrons. P can only contain 6 electrons. D can contain 10 electrons, while F can contain 14 electrons. So for oxygen, so we write the atomic number. So it will now be 1s2, 2s2, 2p4. 1s2. Why this one is 2 is because S can only contain 2 electrons. 2s2. S can only contain 2 electrons. And if we check this order, 1s2, 2s2, 2p4, we are following this order. So why are we putting 4 here? It is just to balance the electronic configuration. If you add these values, 2 plus 2 plus 4 would give us 8. It will give us 8. So let's write for chlorine. Chlorine atomic number is 17. So if we want to write, we use this method. 1s2, 2s2, 2p6. Why? P can only contain 6 electrons. 3s2, 3p. Before we continue, let's add it up. 2 plus 2, that's 4. 4 plus 6, that's 10. 10 plus 2, that's 12. So we need 5 more. We just add the 5 here. Why? Because P can still contain 6 electrons. If it is already more than 6 that we've seen, we will have to continue from 4s. So you can see 2 plus 2, 4. 4 plus 6, that's 10. 10 plus 2, 12. 12 plus 5, that's 17. So that is the correct electronic configuration for chlorine. So let's write for magnesium. If you have any question, please drop it in the comment section. So for magnesium, the atomic number of magnesium is 13. So if we want to write, how do we do that? 1s2, 2s2, 2p6, 3s2, 3p1. Why can't we just say 3s3? The reason is because S cannot contain more than 2 electrons. That is why we have to continue with 3p1. So if we add it together, that will be so aluminum is 12. 1s2, 2s2, 2p6, 3s2. So assuming we are writing for aluminum, we would have gone for this. But since it is magnesium is 12. So it will now be 1s2, 2s2, 2p6, 3s2. So let's write for silicon, and I will leave calcium for you to drop the answer in the comment section. So let's write for silicon. What is the atomic number of silicon? The atomic number of silicon is 14. So if we want to write for silicon, it will be 1s2, 2s2, 2p6, 3s2, 3p2. 2 plus 2, that's 4. 4 plus 6, that's 10. 10 plus 2, that's 12. 12 plus 2, that's 14. So for calcium, drop it in the comment section. So far we started from atomic structure, where I discussed about the introduction to atom, stating that atom is composed of 3 subparticles, which include proton, neutron, and electron. And I explained proton using this diagram, that proton is positively charged while electron is negatively charged. And I discussed about atomic number and mass number. Atomic number is the number of proton in the nucleus, while mass number is the sum of proton and neutron in the nucleus. So to calculate for mass number, the formula for mass number is proton plus neutron, and we cite an example using oxygen. How to calculate the mass number for oxygen. And we also discussed isotopy. It's a very important terminology. We discussed isotopy. Isotopy is a phenomenon whereby same elements have the same atomic number but different mass number, using these examples, using chlorine, carbon, and oxygen. Chlorine has different mass number but the same atomic number, same as carbon and oxygen. And we move to calculation of relative atomic mass. So how do we calculate our relative atomic mass? We use this formula: mass, the first mass given to us, multiplied by the first percentage plus the second mass multiplied by the second percentage all over 100. And we calculated it using this formula. So this is how to calculate our relative atomic mass. So this is the second example. So after that, we move to electronic structure of an atom, where I explain what orbital means and the types of orbital, the SPDF orbital, and I explain the characteristic of each orbital starting from S to F. And I also draw the electronic configuration. You can see the electronic configuration, and we also treat examples. And we wrote the electronic configuration for oxygen, chlorine, and magnesium, and silicon. So drop the answer for calcium, the electronic configuration of calcium. Drop it in the comment section. As we continue. So I'm waiting for you to drop it in the comment section. The electronic configuration of calcium. So another thing that I want us to talk about is shell capacity. So shell capacity is the maximum number of electrons in a shell. So the formula for shell capacity is written as 2n squared. And we have 4 shells. We have K, L, M, N shell. So let's draw out the table. Shell K, L, M, N. We also have this N, which is the number 1, 2, 3, 4. So this is the formula, the shell capacity, 2n squared, and the maximum electron. Each shell can contain. the maximum electron each shell can contain. So 2n square, anywhere we see n, we represent the value here with it. So it will now be 2 into bracket 1 square. Anything raised to power 1 is 1. 1 multiplied by 2 will give us 2. So the maximum electron of K shell is 2. The maximum electron for L, 2 into bracket 2, we represent n with 2 for L, 2 square. So 2 square is 4 multiplied by 2, that's 8. For M, 2 into bracket 3, we represent our n here with 3. So 3 square is 9. 9 multiplied by 2 is 18. For n, 2 into bracket 4 square. 4 square is 16 multiplied by 2, that's 32. So we change n. Since we have the value of n for all, we just change the n to the value and we multiply using this formula 2n square. So as you can see the table, this is the table. So it is very important. For assuming we want to solve for O, it would be 5. It will now be 2 into bracket 3 square. So if 2 into bracket 5 square, 5 multiplied by 5 square is 25. So 5 multiplied by 5 is 25. 25 multiplied by 2 is 50. So I hope we understand the concept now, how to solve for each shell. So I want to list out the 4 quantum number that we have. Quantum number. We have 4 quantum number. We have the principal quantum number. Principal quantum number. We have the azimuthal or subsidiary quantum number. Azimuthal or subsidiary quantum number. We have the magnetic quantum number. Magnetic quantum number. And we also have the spin quantum number. So with what we've done so far, we would be treating practice question on what we've done so far. So we'll be treating practice question. So for the upcoming JAMB exam, if you are interested in our tutorial, just chat this number right here on WhatsApp. Our tutorial is affordable to join. You can join this our tutorial on WhatsApp. Just chat our number on WhatsApp to join the tutorial. Chat this number on WhatsApp to join the tutorial. So the first question, this is JAMB pass question, which you should not take lightly. This is JAMB pass question which you should not take lightly. The element with electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 is A, Ca, B, K, C, 3p6, D, 4s2. So how do we solve this? I said earlier that we need to count the number here. We need to count the electron here. So 2 plus 2, that's 4. 4 plus 6, that's 10. Plus 2, 12. Plus 6, 18. Plus 2, 20. So the answer is calcium. The answer is calcium. The option here should be Mg and Na. Mg and Na. Sorry for the mistake. So the answer is calcium. Why is it calcium? Atomic number of calcium is 20. Atomic number of potassium is 15. Atomic number of magnesium is 12. While atomic number of sodium is 11. So if we so so I hope you understand better now that the elements with of this is calcium. So let's treat another question. So the elements the number the number of electrons in the valence shell, number of electrons in the valence shell of an element of atomic number 14 is A1, B2, 3, D4. So the first thing is to identify the element. The element with the atomic number 14 is silicon. So the number of electrons in the valence shell, how do we know that? We need to know the meaning of valence shell. Valence shell is the like the outermost shell of an atom. How do we know? Let me cite example. On that. So this is an atom. So we start with 2. Silicon is 2, 8, 2. Silicon is 2, 8, 4. 2, 8, 4. How do we know that it's 2, 8, 4? We start using ALMN. I said earlier that K can only contain 2 electrons. L can contain 8. M can contain 18. N can contain 32. O can contain 50. So you see now that is why we are starting with 2. Silicon can only contain 2. N can contain 8. M can contain 18. But if we sum this up 4, that's 14. So the atomic number of 14, the name of that is silicon. So now that we know that, so we start with 2. So to write it, we write it like this: 1, 2, 3, 4, 5, 6, 7, 8. So the outermost shell, the last one here is called the outermost shell. It is also known as the valence electron. So we are left with 4. We already wrote this 2 here. We already wrote this 8 here. 1, 2, 3, 4, 5, 6, 7, 8. Remaining this 4. So that is 1, 2, 3, 4. So if you have to find the valence electron of any valence shell, you use the outermost shell. You count the electron on the outermost shell. And if you count the electron on this outermost shell, 1, 2, 3, 4. So that means silicon have 4 valence electron. Let me cite another example. Let's write the valence electron of calcium. Calcium is 2882. How do I know it's 2882? You can see 2 plus 8, that's 10. 10 plus 8, that's 18. 18 plus 2, that's 20. That's 20. So To write it, we have 1, 2. We write another 8 here. 1, 2, 3, 4, 5, 6, 7, 8. Another 8. 1, 2, 3, 4, 5, 6, 7, 8. So we've written this one, we've written for this one and this one, remaining the last one. So the last one is 1, 2. So that means, which is the outermost shell, that means calcium have 2 valence electron. Calcium have 2 valence electron. So let's move to the next question. Let's move to the next question. A particle contain 8 proton, 9 neutron and 7 electron. Could be written as, this question means a particle that contains 8 proton, 9 neutron and 7 electron could be written as A, B, C, D. So which one is the correct answer? Which one is the correct answer? So before we answer this question, O minus Na plus Al3 plus, which other one? Mg2 plus. So I will explain these four to you now. This O minus means, you know that electron has 8 oxygen has 8 electron. It has 8 electron. So by this negative sign means it's receiving an additional electron. It means it's receiving an additional electron. This Na represents sodium. It means 11. But if plus is added to sodium, this plus sign represents that it is giving out electron. So which means it means sodium will move from 11 to 10 because of the positive sign here. It means it's giving out electron. So for magnesium, this 2 plus means magnesium is donating 2 electron. Magnesium is 12, so it will now move from 12 to 10. For aluminium is 13. This 3 plus means aluminium is donating 3 electron. So aluminium will move from 13 to 10. For oxygen is 16. So if oxygen, this minus means oxygen is receiving 1 electron. Why? Electron is negative. That's negative sign. So this negative means 1, and if it is moving, it will be moving from 16 to 17. It will move from 16 to 17. So back to the question. A particle that has 8 proton, 9 neutron and 7 electron could be written as, option B. Why? Mass number is, this mass number and this is atomic number. Mass number is the sum of what? The sum of proton and neutron. How do we confirm that? Let's check it here. You can see mass number is the sum of proton and neutron. So they give us our mass number as 8. Our proton as 8. Our neutron is 9. So 8 plus 9 is 17. And atomic number is the sum of proton. Is the sum of proton. These questions are very simple. Atomic number is the sum of proton in it. and proton is 8. So that is how we got B as the answer. So you see that it is very simple as A, B, C. If you have any question, please drop it in the comment section so I can attempt the question now. So let's solve more question. So I have another question here. Let me check. So an element has 127 neutron and 82 electrons. 127 neutron and 82 electrons. So its atomic number is A 209, B 105, C 45, D 82, E 127. So how do we know they say an element has 127 neutron and 82 electron? Its atomic number is, I hope we know that proton equals electron. If we come back to this question, it says a particle contains 8 proton, 9 neutron and 7 electron. Do you know that this part, it means it has excessive proton because of this positive sign? It means it is giving out 1 electron. So if we come back here, how do we know our proton? We know our proton because proton also equals electron, and electron is 82. So which means our proton is also 82, which is the correct answer. So I hope we are clear with that. And our neutron is 127. So let's solve one more question. Let me check for one more question. Yes, I've seen one more question that is okay. For elements PQRS, don't joke with this question. For elements PQRS, have atomic number. Don't joke with this question. And if you are interested in joining my ongoing tutorial, just chat this number right here. Chat this number right here on WhatsApp to join my tutorial. So for element PQRS have atomic number of 4, 10, 12 and 14 respectively. Which of these elements is a noble gas? Which of these elements is a noble gas? A, P, Q, R, S. So which of these is a noble gas? So how do we know our noble gas? How do we know noble gas? You know that noble gas are the one that they attain octet rule. When I say they attain octet rule, it means they have a stable structure. And to have a stable structure, if you are writing it, it needs to end with 8. For example, neon. If you are writing neon, the atomic number of neon The atomic number of neon is 10, so it is written as 28. To attain a stable octet rule, it has to end with 8. So we are looking for the noble gas. So neon is a noble gas. So 4, the first one is 4, right? 4 is not a noble gas. Hydrogen, helium, lithium, beryllium. 4 is written as 2, 2. So it is not a noble gas. For this 10 is written as 2, 8. 2, 8. 8 already let us know that it already attained that octet rule. It already attained that octet rule, which means 2, 8, which is also neon, is a noble gas. For 12, 12 is written as 2, 8, 2. You can see that it is ending with 2. It does not attain, and I will explain now. I will explain more about this now. So let's check for 14. 14 is written as 2, 8, 4. You can see now it's ending with 4. And ending with 4 means that it is ending with valence electron of 4. And I said earlier here that this last part is the outermost shell, also known as the valence electron. You can say that we have 2. It means it does not have, it is not complete. It means it is not complete. If we are to write this neon, we will write it like this: 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Nowhere to write. It means neon is a noble gas. It already attained that octet rule. It means neon is complete. But if we are to write any of these, assuming we want to write for 282, 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. We now write for the last one, which is 2, 1, 2. You can see that the last one, which is the valence electron here, is not complete. So it is not a noble gas. So the noble gas is neon, which is represented as Q, P, Q, R, S respectively, 4, 10, 12, 14. So Q is the correct answer, which is option B. So guys, we've come to the end of this video. If you find this video helpful, please make sure you like, share, and subscribe. So far we discussed the atomic structure, isotopy, and electronic configuration. We started from the introduction to the atom, and we also discussed isotopy. And I also talk about the calculation of relative atomic mass, how to calculate relative atomic mass. And we also discussed on how to write electronic configuration, and I explained the meaning of SPDF, the characteristic of SPDF, that S has a spherical shape, P has a dumbbell shape, D has a double dumbbell, while F is a complex shape. And I explained how to write electronic configuration for elements here, and I said you should drop the answer in the comment section. Oh, someone already replied. Someone said it is very simple. Yeah, I am glad you understood it. I am glad you understood it. So now we also explain KLMN, and so we also talk about quantum number. We talk about quantum number. So we also talk about quantum number, and we treated practice question. Don't joke with this practice question. If you need more question, if you need past question, share this number right here to get it. I also offer people free syllabus for the importance for all your subjects that you need for JAMB 2026 and for other things. Just share this number right here if you need past question or textbooks that you need. Share this number right here to get it in a document format. So this video would have to come to an end now. It is more than an hour now. So I will see you in the next one. Keep learning and keep practicing. To join my tutorial, share this number right here on WhatsApp to join our ongoing tutorial.